So in 24, when it says simplify, what that means is we multiply everything we can multiply together. We add everything that we can add together. We do as much math as we possibly can is what simplify means. So when the directions say simplify, all right, and they give us -5 times x times 3 times y. What things, this is all multiplication, what things can we multiply together? What do we have that are like, we would consider like terms or like numbers of variables? What can we multiply together? Frankie? So be specific. So our x's, right? We can multiply these together, right? What else? Yeah, I can multiply those two numbers together. Since this is all multiplication, we can use the commutative property, and I'm going to move next to each other the things that we can multiply together. That is a requirement. You're all taking notes on this because you are going to get something like this again. So here, and I'll put another one of these in our notes. So we want to move like terms together. And then we're going to multiply them. Well, -5 times 3 is a -15. X times x, well, that's x multiplied by itself twice, times y. All right, at the very end of your homework, I want you all to write extra example. All right, I want you to simplify. -6 times a times 3 times a times y times a. I want you guys to simplify that. Alex, tell me what to do. All right, so -6 times +3, okay. Excellent. Go ahead and finish it off. Okay. Excellent. How many of you guys got that? Awesome. All right, the other one I want to take a look at is number 28. You know what? I'm going to put 28 in our notes. What else can I do other than 28? Mateo? All right, let's take a look at 40. I'll put 28 in our notes. All right, so they gave us this table. All right, so they gave us all these n values, 1, 2, 3, and 4. And they told us to complete, God bless you, to complete this table. Now, some of you said to me, I didn't understand what to do. Really? How could you not understand what to do here? They say complete the table. What does this say? What does this right here say? Here? 4 times n. What's my value of n? 1. What's my another value of n? 2, 3, 4. I don't know what was hard about figuring out how to complete this table. Just do this math. So this is 4 times 1, which is 4. Somebody put in my n is equal to 2 for that column. Michaela? 8. What's my next one down from there, Layla? All right, what's my next one down from there, Angela? Excellent. So just read the directions. See if you can figure it out. That's part of your learning, is not someone constantly directing you in what to do. Look at something, figure it out. Part A on this should not have been hard. Someone tell me what I do for the second column. Mateo? 4 to the first power, which means 4 times itself once. So that's 4. All right, how about my next one? What does this one say? What's the math I'm doing for this one? Christiana? No. Remember 4 to the power 2 means 4 times 4. This is 16. Somebody do the next one for me. What does this one say? Alex? 4 to the third power, so off to the side. I'm going to do that. Alex, what do you get? Did you say 48? So 4 times 4 is 16. 16 times 4 is 64. All right, what does the next one say? What's the math for the next one? Audrey? 4 to the fourth power, so I'm going to take that 64 and I'm going to multiply it by 4. So that's 16, carry the 1. That's 24, 25. So this is 256. All of you finish the next column if you didn't do it. All of you finish the next column if you didn't do it. Come on. So that first one should be 1 to the fourth power. What is 1 to the fourth power? Kira? 1. What's the next one? When I substitute that n in. Layla? Excellent. Someone do the next one for me. Come on. Addison. Excellent. And I should see the work on these. Excuse me. All right, how about the last one? Vincent? Is what, 256? Questions on how to fill that table out? Okay, part B said, for what values of n is each sentence true? So we want to know what n, must say n equals with a question mark. And the first one is, for n equals n to the fourth. Well, once you filled out the table, these should be easy because you're just looking at the table. So someone tell me, for what value of n is 4 to the nth power the same as n to the fourth power? Okay, so what you're doing is you're looking at these two columns. And you are seeing when they are equal. Come on, you guys. Put on your thinking caps. Think. Stop making me think for you. Emerson. Okay, so we say when n is equal to 2, and when it's equal to 4. Is that what we're saying? How many of you guys agree with that? All right. So when n equals 2 and when n equals 4. All right. How about the next one? We want to know what n is when 4 to the nth power is less than n to the fourth power. Figure it out. Figure out which columns you're comparing. Figure out when this is the case and tell me what value of n it is. Come on, all of you are doing this, please. Dominic, you're thinking, please. Kira? Say that one more time. Third power. So let's take a look. We want to know when n to the fourth is less than n, when 4 to the nth is less than n to the fourth. For 1, it's not. For 2, they're equal, so I agree with you. N to the third when n is 3. All right, the next one is, for what n value do we have when 4 to the nth power is greater than n to the fourth power? So what value of n is this the case? Mia? You've got to talk louder. So what value of n is that the case? When n is 4? Well, when n is 4, these two are equal to each other. When n is 1, that's when then this column is greater than this column. This is something I'd give you on a test. You have to be able to use your brains. All right, put this away, get your notes out. We're going to practice a couple that have those negative bases, and then we're going to move on, okay? But I want to put those in your notes. Okay. I want you guys to compare these two things. What's the difference between those two expressions? What's the difference between those two expressions? Mia? And one isn't, right? All right. So here we have the negative 1 in parentheses. Here the negative 1 is not in parentheses. That's pretty easy observational skills. I hope you guys all had. Okay, so let me ask you guys something. This is kind of an off to the side thing. If I have x, what is its coefficient? So I just want you to do this over here. If I have x, what is its coefficient? Aaron? Yep, that's a 1x. That's 1 times x. If I have a negative x, what is its coefficient? Aaron? This is negative 1 times x. Are you guys all cool with that? Okay. So I want to take a look at that negative 1 to the 8th without the parentheses. Negative 1 to the 8th is the same thing as negative 1 times 1 to the 8th power. That's what that means. So if I have negative 2 to the third, that's negative 1 times 2 to the third. If I have negative 3 to the fourth power, that's negative 1 times 3 to the fourth power. Can you guys see how that works? So the base of my power of 8 was just a positive 1. If I look at that negative 2 to the third power without the negative 2 in parentheses, that's negative 1 times 2 to the third power. The base is simply that 2. And the same thing with that last one. That power of 4 is on just the 3. Alright, so if I compare these, negative 1 in parentheses times 8 to the 8th, negative 1 in parentheses to the 8th power. This means negative 1 times negative 1, 8 times. God bless you. 1, 2, 3, 4, 5, 6, 7, 8. That's what that means. Alright, so all of these, negative 1 times 1 is 1. Negative 1 times 1 is 1. I'm just going to kind of keep going. So here we end up just having a 1. Versus negative 1 without parentheses to the 8th power. This is something you're just going to have to remember. I don't really know a cool way to show it to you other than the way that I am showing it to you. I'm trying to have you guys connected to something I think you guys already know. That if I have a negative x, that's really negative 1 times x. This is the same idea. So this is really negative 1 times 1 to the 8th power. So this is negative 1 times 1 times 1 times 1. That's 3, 4, 5, 6, 7, 8. So in the end, this equals a negative 1. Alright, so if I use that in a different setting, if I give you, I want you to simplify. If I say negative 3 squared times a quantity of 4 minus 2 squared plus 1. God bless you. So we always simplify inside the parentheses first. So what does simplify inside the parentheses mean here? What does simplify inside the parentheses mean on this one? Here? So hang on. I have 4 minus 2, which is 2, to the second power. No, I'm not adding it to 1. I can't add it to 1. I still have a power there. Plus 1, right? So I did my parentheses work. In order of operations, what's the next thing I have to do? Check the exponents. So this first one is negative 1 times 3 squared. So don't forget, that's what that looks like. Alright? Times 2 squared plus 1. I just wanted to rewrite that so you could see that. So we end up with a negative 9 times 4 plus 1. Now what? Order of operation should be something that is innate to you that you can do in your sleep. What do I do next? And here, please don't say adding 1. Adding 1 is at the very end when you've done everything else but just addition and subtraction. That's order of operations. What's my next thing I'm going to do? Christiana? So what are you going to do? What do you get? So negative 36 plus 1. So here, Christiana, what's left? Alright? So please remember, some of you I asked this question to as I was walking around. I said something like, was that negative 3 in parentheses? You've got to make sure that you know if a number is in parentheses or not. So if I give you something like this, and I'm not going to do this one all the way because I have a new lesson for you, but if I gave you something like number 36, and I say evaluate 8 minus x to the third when x equals negative 2. For me to do this problem properly, you cannot do adding the opposite right now because I have an exponent. We're going to leave that till the very end. So I have 8 minus, in parentheses, negative 2 to the third. If you did this, 8 minus negative 2 to the third, I will mark you down. Because this does not say my base is a negative 2. This, putting it in parentheses, says my base is a negative 2. Do you guys understand? And then we would go from there. All right? Okay, put this away, get your notes out. We need to, oh, you have your notes. Let's start, I'm going to start, flip to a new page and write 4.3 because we're starting 4.3. All right, so 4.3, which is prime factorization. All right, that's what we're going to start today, is prime factorization. All right, okay, so first of all, we need to talk about prime numbers. What does a number mean if I say that it's prime? What does a number mean if I say that it's prime? Mateo? No. I like how you're thinking, though. I'm so happy when you guys raise your hand, even if you're not sure if you're right, because that means you're thinking. Addison? Okay, excellent. Give me an example. So 7. Yep. So there's only one number it can be divisible by. And what is that one number always? Angela? 1 for sure, but that's not what makes it prime. And itself, absolutely. So prime numbers are numbers that have factors of 1 and itself only. It is very important you know your prime numbers. All right, up to a certain point. What does composite numbers mean? So a number is either going to be prime or it's going to be composite. There's only one number that's neither. All right, what does composite numbers mean? If prime means that they have factors of only 1 in itself, Mateo, what does composite mean? Excellent. So these are numbers that have factors of more than 1 in itself. There's only one, like I said, there's only one number that's not prime. It's neither prime nor composite. What number is not prime and it's not composite? What do you think? Romano? 0. So 0 is neither prime nor composite. That's the only exception. So let's talk about prime numbers. Let's do prime numbers up to, let's say, 20. Give me my smallest prime number. And I want you guys thinking those in the smallest. Smallest prime number. Jack? Not 1. I mean, we could say 1. I suppose 1 is neither prime or composite. We'll say 1. Give me another prime number. The smallest. Mateo? Nope, that's not the smallest. Alex? 2. I know that seems weird. But 2 only has factors of 1 and 2. Right? I mean, I know it goes into a lot of numbers, but it only does have factors of 1 and 2, right? So, Mateo, yes, I agree. 3 is the next one. What's the next one up from there? Michaela? 5. What's the next one up from 5? Emerson? 7. What's the next one up from 7? And it's not all odd numbers, although from here on out, probably the rest of them are odd. 2 is probably the only one that's not odd. That's the only one prime number that's not odd, right? That's kind of fun to remember. All right, Audrey? 11. What's my next one up from there? Christiana? 13. What's my next one up from there? Dominic? 17. What's my next one up from there? There's one more. Aaron? 19. All right, so knowing them up to 20 is really important. All right, so let's talk about prime factorization. Because we're going to be using prime numbers, obviously, in our prime factorization, so you need to know your prime numbers. Okay? So prime factorization, who remembers what that means? I think you guys used the birthday cake method last year as one of the methods. Do you guys remember doing that? So what does it mean to put a number in its prime factorization, or do prime factorization on a number? What does that mean? Aaron? What factors? Yes, it's finding its prime factors. So prime factorization is the process of breaking a number into its prime factors. And that's the key. It's not any factors, it's its prime factors. Because we're going to be using these to find greatest common factor and least common multiple. Okay? All right. The process that I require you use is a prime factorization tree. Okay? So we are going to use a prime factor tree. So I recognize that you guys know how to use a birthday cake method. All right, so I want you guys being very proficient, because birthday cake method does not work on more than two numbers you're finding the prime factors for. All right, you have to have prime factorization, and it doesn't necessarily work when we have exponents. So I need you, or not exponents, variables. All right, so prime factorization works with a factor tree, works for all of them. All right, so let's practice what that means. Who needs to see what's up there? Okay, so let's do a couple of these. I'm just looking at your homework to see what I've given you. Okay. So I want you to do the prime factorization. Here's my first example. So let's do prime factorization of 72. All right, so what we're going to do, I'm going to write this over here to kind of give myself some room. You're going to break 72 up into two of its factors. It doesn't matter what you start with. This is when you use your divisibility rules if you're not sure. What number do I know 72 is divisible by? Jack? 2. It's definitely divisible by 2. But what else, if 2 didn't jump in your head, what did jump in your head? Because you know your multiplication facts. Audrey? 3 and what? I'm not saying what else is it divisible by. Some of you can look at a number, and like if you look at 36, some of you are like, oh, that's 6 times 6. And I'm immediately going to write 6 times 6 down. If you look at 72, if you did not see 2 and you're like, I'm just going to try 2, what do you know for sure are two factors that jump right into your head? Vincent? What'd you say? 9 and 8? Is it 9 and 8? Yeah. All right, so we're going to start with that. If you thought of something else, then use something else. Because there's more than two factors that you could, two factor pairs that you could start with. You just need to start with two factor pairs. So 9 times 8 is 72. Now I'm going to break these down. What can I break 9 into? Mateo? It's not just 3. How about 3 times 3? So 3 times 3. What can I break 8 up into? Edison? So 4 times 2. All right, well 3's prime, 2's prime. I like to circle my prime numbers so I know I'm done when all of them are circled. Is 4 prime? All right, so somebody break 4 down for me. Go ahead, Romano. 2 times 2. Those are prime. So what I require that you do is we're now going to write 72 equals, and I like to write them in order of least to greatest. I want you to do that. It's a good habit, especially when we use them. 2 times 2 times 2 times 3 times 3. All right, now use exponents. So somebody tell me what the prime factorization of 72 would be using exponents. Kira? Excellent. All right, I want all of you doing this one real quick, and then we'll be done. I want you to do the prime factorization of 225. Come on. You might have to do a little bit of division here, just to get you started. What number do you know it's divisible by? Layla? Okay, if you saw 9 and 25, that's great. How many of you guys just saw 5? Yeah, I would have started with that as well. So however you start, go with it. 5 times what gives me 225? Alex? What'd you say? 45? Okay. How many of you guys got 5 times 45? Okay. 5 is prime. I'm going to use this one. If you use a different one, that's fine. 45 is 5 times 9. 9 is 3 times 3. So whether you started with 5 and 45 or you started with 9 and 25, you're going to end up with the same thing. So I have 225 is equal to 3 times 3 times 5 times 5. Yes, I want to see that written out. So all that I'm showing you is what I want to see. Dominic, how can I write 3 times 3 times 5 times 5 using an exponent? What? Excellent. Excellent. You guys cool with this? Okay.